Good evening, 7th grade, and this is lesson 7-2 on solving multi-step equations. Last night we looked at how to solve 2-step equations. So this time we're going to learn how to solve 3 to even 4-step equations. So our objectives tonight are you will be able to combine like terms to simplify an equation, and you're also going to be able to use the distributive property to solve an equation. Now, we've done this before as a warm-up. I'm just going to do a quick little reminder. When we simplify an expression by combining like terms, you look at the things or the terms with the exact same variable. So here we have a 2x plus a 3x. So we really have 5x plus 4. Here we have a 5y plus y. Well, that's the same as adding 1y, so that's 6y. Here we have 8a minus 5a. Well, that'd be 3a. All right, that's going to be very useful in tonight's lesson, especially the first part, because tonight's lesson is really broken down into 3 parts. First, combining like terms, then we look at consecutive integers, and then finally, we are going to look at the distributive property. So first things first, combine like terms to simplify an equation before you solve it. That's what we're going to do first. So here I have this equation. M plus 2m minus 4 is 14. All right, so we look at the side with the variables, and we have an m plus a 2m. So we need to combine those before we can do the 2-step equations like we did yesterday. Well, if I have an m, and really, again, that means 1m. Really, I have 1m plus 2m, that is 3m's, minus 4 is equal to 14. Well, now if you look at it, this is like those problems we had yesterday. I undo addition or subtraction, and now I'm left with 3m is equal to 18. Now we have a 1-step. I undo the multiplication by dividing by 3, and I have m is equal to 6. So again, I could go to the original and say 6 plus 2 times 6 minus 4 and see if that's 14. Well, 6 plus 12 minus 4. 6 plus 6 is 18 minus 4 is in fact 14. So those check. So here we have a word problem of this one. In his stamp collection, Jorge has 5 more than 3 times as many stamps as Helen. Together they have 41 stamps. Solve this equation. S plus 3 times S plus 5 is 41 to find the number of stamps each one has. Well, again, all of this comes from the information given. So again, we'd solve it. Look for those like terms. I have an S plus 3S, which is equal to 4S, plus 5 is 41. I subtract 5 from both sides, and I'm left with 4S is equal to 36. Divide by 4, and I have S is equal to 9. So, all right, one person, Helen, I believe, just has 9 stamps. So Jorge has 5 times more than 5 more than 3 times as many stamps as Helen. So if Helen has 9 stamps, well, 3 times that is 27, plus 5 is 32. So Jorge has 32 stamps. We had to go back to the original because if I would have stopped at 9, I wouldn't have answered the whole question, which was find the number of stamps each student has. Now it's your turn. I have another word problem for you. One basketball team defeated another by 13 points. The total number of points scored by both teams was 171. Solve the equation P plus P minus 13 is the same as 171 to find the number of points P scored by the winning team. So again, this is your equation that you need to solve. So go ahead and solve it, and when you're all done, come back and check your answer. So pause me now. All right. So let's get started. Again, we'd have 2p minus 13 is 171. I'd add 13 to get my answer. And I'm left with 2p is equal to 184. Divide by 2, and I'm left with, oh, there we go. P is equal to 92 points. So let's make sure that's what I'm supposed to get. One team defeated another by 13 points. The total number of points scored by both teams was 171. Find how many points was scored by the winning team. Well, just to make sure this was the winning team, I'd say we try it out. We know one team scored 92 points, so I'm going to subtract that out. 979. So the winning team scored 92 points, while the losing team scored 79. So really all we needed in this case was the 92 points. So that's the first part of your lesson. Now this next part goes right into it because we're talking about consecutive integers. When we talk about consecutive integers, those are numbers that are right next to each other. You're basically counting by one to get to the next one. An example of that is if I go 120, 121, 122. Those are consecutive. Or you can do it with negatives, negative 11, negative 10, negative 9, and so on. Those are consecutive. So here, for example, 2, they say the sum of 3 consecutive integers is 42. Find the integers. That's all they're telling us. There's 3 numbers that they're right in a row that equal 42. We need to figure out what they are. All right, but they don't give us a lot of information. We just know there are first 3 terms. There's a first, a second, and a third. All right. Now, normally when I say if you don't know something, we usually put in a variable, right? So we're going to say the first one is x because that's all we know. There's some term out there, and that's what we're going to label it, x. The thing we know about the second one is that it comes right after the first. Well, if I was at a number and I want to get to the next, well, I would add 1 to it. Because if I take x and add 1, that gives me the term right next to it. And of course, for the third term, I'd add another 1, so I'd have x plus 2. This here gives me those 3 terms in a row. All right, because I have my first number, my second, and my third. Now they say, I go back to the original, the sum of these is 42. Well, I'm going to add them together. X plus 1 plus x plus 2 is going to equal the sum of 42. Well, and if you look at this, we need to combine like terms, just like we were doing. I have an x plus 1 more x. Well, that gives me 3x. Then I have plus 1 plus 2 is equal to 42. Again, I could add plus 1 plus 2 and do plus 3 right away and get 42. Now I have those problems, so I subtract 3. 3x is equal to 39. Divide by 3. And I have x is equal to 13. So my first term is 13, but they want all of them, so I'm going to say it's 13, 14, and 15. Now before I circle my answer, I want to make sure I'm right. So I'm going to actually add those together to be sure of it. So 13 plus 14 plus 15. Let's see, 9, 10, 11, 12. Well, would you look at that? It equals 42, just like it's supposed to. So those 3 terms are 13, 14, and 15. Your turn. This time there are 4 consecutive integers with the sum of 358. You need to find them. So go ahead and do what I did before. Just put the 4 there and think of what you'd label them. So go ahead and pause me now. All right, let's find those 4 terms. Again, this time there's 4 we're dealing with. So we have our first, second, third, and fourth number. Well, we always label the first one x. The next one is going to be 1 more than that, so x plus 1. The next one will be 1 more than that, so x plus 1, or x plus 2. And the one after that's going to be just 1 more, so x plus 3. Now we have to find the sum. So x plus 1 plus x plus 2 plus x plus 3 will be the same as our sum of 358. Combine like terms. I have 4x plus 6 is equal to 358. Again, I subtract 6. I'm left with 4x is equal to 352. And I divide by 4 to find my answer. So if I do that, 352 divided by 4, I get 88. So my 4 terms must be 88, 89, 90, and 91. They always give you the first term when we do this. And again, you could go ahead and check it if you wanted to, but I'm feeling pretty confident with that. Now, here is where they can kind of trick you with these consecutive integers. Sometimes they say consecutive even integers or consecutive odd integers. All right? When they say that, they're not any longer n plus 1. Right? Because if I'm talking, for example, here, find two consecutive even integers with the sum of 66. So I know there are two terms, a first and a second. All right, I still label this first one x because it's some even number out there. But I can't label this one x plus 1 because if I do one more than an even number, for example, if I said it was 12, well, one more than that is 13. If it was 20, one more than that is 21. So when we're talking about even or odd consecutive integers, you actually have to add 2. So here it's x, and then their second term is x plus 2, because you have to skip that odd number between the two of them. So here, our first term is x, our second one is x plus 2. So find the two consecutive integers. Well, x plus 2 is 66. Combine like terms, 2x plus 2 is 66. And we just go through those same steps that we did before to solve what our first one is, and x is 32. Well, if x is 32, our second term is 2 more than that, so it's 34. 32 and 34 are our terms. Okay, so that is the second piece of our lesson. The final part tonight is about using the distributive property to solve. Now, we've used the distributive property before. That's just when you use the number on the outside and multiply it by everything on the inside. So here I have 4 times x plus 4 times 2, which is really just 4x plus 8. All right? Or if you're dealing with a negative number, then it's negative 3 times y, and so on. Negative 3 times y minus a negative 3 times 1. So if we do this one, we have negative 3y minus a negative 3. Well, two negatives in a row make a positive. All right, so we've done those before. But now we're going to use them in equations. So we're going to go ahead and do A together. So we have 4 times the difference. 2 times q minus 7 is negative 4. Well, again, you start by taking this 4 to everything inside of it. So 4 times 2q minus 4 times 7 is going to equal negative 4. And if I do this, 4 times 2q is 8q. Minus 4 times 7 is 28, is negative 4. Then we solve it. Well, I add 28 to both sides, and I'm left with 8q is equal to 24. Divide by 8, and I have q is equal to 3. All right? It's the same idea with this one again. All right, and I would like you to solve this one with me as I go along because there's actually an extra step added into here. 44 is equal to negative 5 times r minus 4 minus r. So here, again, you start with the distributive property. You can't combine like terms with these parentheses in here. So we do 44 is equal to negative 5r. All right, then we have a minus negative 20, and then we have that minus r. Well, again, we talked before, 2 negatives in a row make it a positive, so I'm going to clean that up a little bit. There we go. So now I have 44 is the same as negative 5r plus 20 minus r. Well, this time we have to combine like terms before we can actually solve. So if I have a negative 5r and then I'm subtracting another r, it's just going to get more negative. So I have 44 is the same as negative 6r plus 20. Now I can solve it. So we undo the 20 by subtracting it, and we're left with 24 is the same as negative 6 times r, and divide it out, and we have r is equal to negative 4. The end. All right, that is our lesson for tonight. Tonight we talked about using, like terms and the distributive property in order to solve multi-step equations. Have a great night. I will see you in class tomorrow. Good night.